All right, and let's continue on looking at some ACT problems. And the next one we're going to look at, we'll call this number 1 for this, says that we have a triangle ABC. Let's see, can we draw a triangle ABC? Yeah, not too bad. Here's triangle A, B, C. And it says that sides AB and BC are equal. And then they gave us this angle down here and said that was 70 degrees. And they want to know the measure of angle A. Well, hopefully you realize that this is an isosceles triangle, and if angle C is 70 degrees, well then angle B had better be 70 degrees, and that would make A equal to 180 minus 70 minus 70, which back in the day used to be 40, and that's 40 degrees. So the measure of angle A is 40 degrees. Right? And the key here is knowing that this is an isosceles triangle, and the angles opposite the congruent sides are also congruent. All right. Now, let's move on to the next one, another triangle problem. And this one is a goodie. Again, they give us a triangle. And they draw in an altitude. Number 2. And they say a triangle, and it's ABC, is an equilateral triangle. Okay, I didn't draw an equilateral triangle. That means that all 3 sides are the same. That's an equilateral triangle. And it says that AH, we'd intersect down H here, is perpendicular to BC and has a length of 2 square root of 3 inches. Now they want to know what's the area in square inches of triangle ABC. Well, remember that for a triangle, area is 1/2 base times height. So, well, we know what the height is. That's 2 square roots of 3. That's section AH. And now, because this is an equilateral triangle, if we could figure out how long AB, AC, or BC was, we would have a base that we could use. An important thing to remember is that when you have an equilateral triangle and you have a segment that bisects the side opposite that side, it is also a perpendicular bisector to that. So again, my triangle does not look the same, but BH and BC are the same length, right? This is definitely not to scale. Okay? And remember, they may do that to you on the ACT because, of course, they are sneaky little buggers. Right? You thought I was going to say something else, but they're sneaky little buggers. Okay. So, well, what do we know? Let's see. Alright, what do we know? What do we know? We know that this is a 30, 60, 90 right triangle, and we know one of the sides adjacent we know one of the legs of the triangle. Well, we want to know this opposite side over here. So, well, the tangent then of 30 degrees is going to equal, we call that x, I suppose, is going to equal x over 2 square roots of 3. Now, the question is what is x? How do you do this? How do you do this quickly? Calculator, quite honestly. If you crank this through, you'll get x equals, ooh, see if I can't do that in my head. Oh man, it's late. Tangent 30 times 2 times square root of 3. That equals 2. That's what I thought. So, what we're going to have for the area then, the area equals 1/2 times the base, which is 4, times 2 square roots of 3. And why is the base 4? Because remember, half of this was 2. That would make the other half 2 as well. 2 plus 2, still 4. So the area is 4 times the square root of 3. Okay. Again, if you wanted to turn these things into decimals, probably not the most prudent thing to do with this. I would do on my calculator. Now, the other thing you guys should all do is make sure that you're in degree mode. You might want to do that right now with your calculator. Right. Tangent 30 times 2 times 3 to the 1/2 power will give you 2. That you can enter in your calculator. It will give you 2. That's something, I mean, if I'm sitting here trying to think about doing that in my head, you probably shouldn't attempt it. Use your calculator. Now, moving on. Let's see. Oh, yes. This is the problem that I really, really like. Okay. It says that 0 is less than x, and x is less than 2, which is less than y. This becomes a process of what you can eliminate. Here are your choices. X is less than xy divided by 2, which is less than y. Now, b is 0 is less than xy, which is less than 2x. Part C, x is less than xy, which is less than 2. D, 0 is less than xy, which is less than 2. And part E is just x times y is less than y. Okay. Now, this looks daunting, and there's one, if you know the rule, you can look at it and go, clearly it's this one. I'm thinking most of you don't know the rule. So, I'll talk about the rule in a second, but let's see what we can get rid of first. X and y, both of the variables here. Now, if x is between 0 and 2, that means that x could be a fraction, or it could be something like 1.9. And they're telling us that y is greater than 2. Okay, so y could be 456,000. Now, so if x is 1.9 and y is 456,000, x times y is never, ever, ever going to be less than 2. So you know what? These two things just go away. We came up with a counterexample. Now, the other thing with our counterexample is if x is 1.9 and y is 456,000, 1.9 times 456,000 is almost 900,000. That's not less than 456,000, so right away, E is gone. Okay? Now, again, using our example, x is 1.9, y is 456,000. If x is 1.9, 2 times 1.9 is about 3.8. Okay? 1.9 times 456,000 is a little bit north of 1.8. So right away, that one is now gone. Okay, we've gotten rid of 4 answers. That tells us that A has to be correct. And that is the correct choice. Now, the thing I said about there's a rule, but I don't think that you guys know what the rule is. Now, when you think of an average, you always think about an arithmetic mean, where you take and you add everything up and you divide by how many there are. That's an arithmetic mean. That's what's commonly referred to as an average. There's also something called a geometric mean, where you multiply the two numbers together, divide by 2, and you will find the middle value. That's what we have right here, is they found a geometric mean. And well, the middle between x and y would have to be greater than x and less than y. This is quite literally the definition of a geometric mean. All right, so that's that one. Again, a little example of how we can go through and get rid of some of these things if you just think. I mean, you know, fine, y is greater than 2. Pick something ridiculously bigger than 2, because they didn't put an upper bounds on it. Let's move on. Okay, let's see. Yeah, this one's not so bad. They gave us 4x equals negative 3y plus 8. Now, and they want to know what the slope of this line is. This is a linear equation, and I know you guys are used to looking at y equals mx plus b. Okay, well, this thing doesn't look like y equals mx plus b, so let's make it look like y equals mx plus b. Let's have these two things switch sides so that we got 3y equals negative 4x plus 8. Right, all I did was subtract 4x from each side and add 3y to each side. Okay. Now, I'm going to divide everything by 3. And y is going to equal negative 4/3 x plus 8/3. Well, guess what? The slope is negative 4/3. Right? Nice little problem there. Okay. I think we're going to end part 2 right here, and we'll pick up with part 3.